Finally, after 70 days of research and discussions, NASA has made a firm decision regarding the fate of the Starliner spacecraft. But what about the fate of the two astronauts? All will be revealed in today's episode of Alpha Tech. And before getting into the main content, I got to tell you, thank you so much for supporting our channel these last 3 years. Right now, we got 86,000 subscribers, so close to 100,000. To hit this milestone, we need your help. So please press that subscribe button now, and that way you are guaranteed to never miss out on any of our exciting daily videos each day. All right, let's continue. Two astronauts getting stranded in space might sound like the plot of a Hollywood sci-fi movie, but for two NASA crew members, it's now become the reality. Commander Barry Wilmore and pilot Sunita Williams are currently in limbo aboard the International Space Station. Meanwhile, the concluding meetings are still ongoing, and the most recent one was held on August 14th. The space agency gave an update on Boeing Starliner's troubled test mission, and unfortunately in this mission, we got some useful information about the ill-fated spacecraft, often referred to as Stuckliner. During the meeting, NASA finally set a return date for the cursed spacecraft. According to a famous space journo, whom I greatly admire, Eric Berger, he said NASA's tentative date for Starliner's undocking from the ISS is September 6th, whether the craft is crewed or not. This means that whether the two astronauts on board Starliner return or not, the spacecraft has to undock from the space station by September 6th. This extends the original test mission, planned for 8 days starting June 15th, to a total of 12 weeks, precisely 93 days. In fact, Starliner's batteries were only designed to hold energy for 45 days, and Boeing and NASA have found a way to double this stay time to 90 days. However, since more than 6 weeks have gone by, the batteries have been recharged at the station, but they can only continue to provide power for a limited time before they completely go kaput. This is an extremely urgent situation, leading NASA to possibly lose confidence in the new spacecraft's capabilities. Instead, Ken Bowersox, deputy admin of NASA's Space Operations Mission Directorate, announced that before the end of August, NASA would conduct a high-level flight readiness review to make a final decision on the fate of Starliner. The specific decision will determine whether the two astronauts will return on Starliner or if they'll stay on Dragon until 2025 for their return. It's a fairly major discussion to decide about whether or not we're going to have a crew on board Starliner for return, Bowersox said. We've got time available before we bring Starliner home, and we want to use that time wisely. We're expecting that the data analysis will be ready for a flight readiness review around the end of next week, potentially the beginning of the following week. If NASA decides to bring Wilmore and Williams home on Starliner, Bowersox said that the agency would have to accept more risks than officials initially anticipated. NASA officials can't quantify the additional risk that the propulsion system might pose to the astronauts if they return to Earth inside the spacecraft. On August 2nd, Boeing stated that they remain confident in the Starliner spacecraft and its ability to come back safely with crew. However, NASA officials have not expressed a similar confidence. At a meeting called the Program Control Board meeting earlier this month, NASA managers asked reps from various groups involved in Starliner whether they were ready to give the green light for Boeing's spacecraft to come back to Earth with a two-man crew. Many board members said no, leading NASA to postpone the senior agency officials meeting to assess flight readiness, which was supposed to make the official go or no-go decision for Starliner's journey home. Bowersox mentioned that engineers would try to model the valves operation with a swollen Teflon seal next week and its impact on the thruster's performance. Managers will evaluate the model data along with other test results at another Program Control Board meeting later next week. After that, NASA's leadership will convene a flight readiness review chaired by Bowersox. If there's no consensus from that review, the final decision might fall to NASA's highest-ranking civil servant, Jim Free, or a NASA administrator, Bill Nelson. There is some degree of risk in extending Wilmore and Williams' stay on the ISS and bringing them back to Earth on the SpaceX Crew Dragon spacecraft early next year. If that happens, the astronauts would have to remain in orbit for more than 8 months, and things could go wrong during the spaceflight. Their initial flight plan called for just an 8-day stay at the outpost. If NASA does decide to detach Starliner from the space station without the astronauts on board, there will be a brief period when the only way for Wilmore and Williams to get home is on the SpaceX Dragon spacecraft currently docked at the station. In that case, Dragon would have to re-enter the atmosphere with a 6-person crew, opposed to the usual complement of just 4. Wilmore and Williams would not be wearing pressure suits during the trip back to Earth. If this is how NASA proceeds, 2 launch and entry suits made by SpaceX for Wilmore and Williams will be sent up on the next Dragon mission at the end of September. This Dragon spacecraft will launch a two-person crew instead of a four on a 5 or 6 month expedition, leaving empty seats for the Starliner astronauts to occupy it when it returns to Earth next year. Furthermore, the situation creates a dreadful waiting period. Waiting for things is difficult at the best of times. Under normal circumstances, it's frustrating, stressful, and gives us anxiety. But in extreme situations with high stakes, waiting can be purgatory. For the astronauts stuck on the ISS, anxiety about when they'll return, limited opportunities for activities, and fewer opportunities to contact friends and families combine to make their wait to return home feel much longer than 6 months, if it should come to that. So, what are the final questions that all of us are wondering about in the discussion regarding Starliner? First, could NASA delay the decision again? At the press conference, Bowersock said that it's getting a lot harder to delay the decision. He cited consumables and the need to use the ISS ports for cargo missions as reasons to avoid postponing the decision of whether or not Starliner returns crewed or empty much longer. We're reaching a point where the last week in August we should really be making a call, if not sooner, Bowersock added. The second question is, if Starliner returns without astronauts, does that mean NASA will end its mission to seek a backup plan in space? NASA leads its commercial crew program to be able to pay multiple companies to send its astronauts to space. Boeing and SpaceX are considered different backup options or alternatives in case one company can't provide the service of sending astronauts to space or bringing them back in an emergency. All I can say is that our intent is to keep pressing to have two providers, Bowersock said. We got two very good companies, and we want to develop two strong and capable spacecraft. We think we got a good chance of doing that, but the answer is always in the data, right? That's what we're doing this mission. Well, either way, NASA's statements indicate that they still want to maintain and continue using Starliner for future missions despite the unresolved issues. In fact, the problems with Starliner have yet to be clearly identified by Boeing and NASA because they haven't been able to figure them out. That's also why NASA is taking the remaining days to make a decision about Starliner's limited reusability. The crew capsule itself is designed to be recovered and flown again, but the faulty thrusters are housed in a part called the service module, which is jettisoned before reentry and burns up in the atmosphere. This makes it impossible to conduct any kind of technical inspection after the spacecraft returns, and thus NASA is trying to gather as much info as possible from the telemetry data and monitoring before the service module gets lost forever. At the August 14th press conference, one reporter asked if it might be possible for a station astronaut to perform a spacewalk to assess the state of the thrusters. A suggestion Joe Acaba, the agency's chief astronaut, quickly shot down. "We're not doing a spacewalk," he said. "The way the system's designed right now, we just don't get this hardware back, and there's not much we can do in real time." In the past, NASA might have been willing to push the crew a little harder, challenging those 1 in 270 odds and flying Wilmore and Williams home in a less than perfect ship. Astronauts have made it back to Earth in much more damaged spacecraft in the past, notably Apollo 13, which suffered a near catastrophic explosion on its way to the moon in 1970. Then there was Gemini 8, which spun out of control in orbit in 1966, nearly costing the lives of astronauts Neil Armstrong and Dave Scott before Armstrong wrestled the ship back under control and then hightailed it home. However, the twin losses of the Shuttle Challenger in '86 and Columbia in 2003 have left the agency much more risk-averse and led to institutional changes designed to encourage mission managers to raise concerns well in advance of such tragedies. For me personally, I've been very hyper-focused lately on the concept of combating organizational silence, said Russ DeLoach, chief of NASA's Safety and Mission Assurance. If you look at both, unfortunately, Challenger and Columbia, you can see cases where some people had the right data or a valid position to put forward, but the environment just didn't allow it. Challenger launched immediately during a Florida freeze, contributing to its foreseeable explosion, and Columbia was flown home when it was not fit to re-enter the atmosphere. A rescue shuttle might have helped save that crew. That new caution leaves Wilmore and Williams stuck. Starting with the first Starship launch in early 2023 and having conducted 3 launches since then, SpaceX has made some awesome changes and upgrades to its Starship program. One's got to ask if any other rocket company could do what SpaceX has done in just a year. I'm pretty sure no one could, not even the leading aerospace agencies of the world's superpowers with decades of experience. When it comes to Starship changes, the first thing we need to talk about is the modifications to the nose cones and the oxygen and methane fuel tanks of Starship's second stage. Recently, we got a first-hand look at the nose cones that SpaceX has decided to replace across the new variant of Starship. I'm not sure if they'll make further changes to the nose cones in the future, but what we're discussing here is the latest hardware that SpaceX is currently manufacturing. Zoom in closer to the nose cone design. In terms of shape, when compared to the previous nose cones used on Starships up to Starship 32, these new nose cones are slimmer and longer. Of course, the base diameter still's got to be 9 meters. The lifting points at the nose have also been streamlined. This is where the lifting mechanism connects to stack the nose onto the lower sections. In the current version, each ship has 6 lifting points. V2, though, only has 4. This potentially reduces attack surfaces, and the 4-point design could create more balance when lifting compared to the 6-point design. Work's progressing on these hardware components as their heat shield attachment points are gradually being completed. We'll have to wait a bit longer to fully understand all the new features on these nose cones. On top of that, both the liquid oxygen and liquid methane tanks have been redesigned by SpaceX. The new slanted design includes an integrated funnel inside. The old one essentially had a single pipe sticking to the side, so this change could be related to managing fluids both horizontally and vertically, ensuring stable fuel flows at all stages of the flight and the spacecraft changes orientation or experiences various accelerations. Moreover, this change improves efficiency compared to the previous design, while the new version allows them to use the entire volume of the manifolds instead of leaving some at the bottom as the spherical manifolds did. The conical structure connected to the nose also replaces the previous struts. Let's look at the before and after versions of SpaceX's changes. Also located at the nose cone, the flaps have undergone changes that many have heard Elon mention after the 4th launch. Elon revealed that the position of the flaps would shift towards the lee side. Previously, the flaps were positioned symmetrically at a 180-degree angle, but now they'll form an angle of about 140 degrees. This adjustment helps the flaps avoid direct impacts during re-entry. Additionally, it seems that the flaps have been moved closer to the top of the ship. This change could improve maneuverability by shifting the control center of mass forward and balancing with the rear flaps. In terms of shape, the new flaps are smaller and sharper. The upper and lower edges are longer, while the trailing edge is shorter. The effectiveness of this design might be debatable, so feel free to discuss your thoughts down there in the comments. Along with the changes to the flaps, the heat shields in this area have also been upgraded. On the nose cone, the heat shield has been extended towards the lee side. This extension provides better protection for the vehicle and acts as a backup safeguard for the shield and the fuel tanks inside. Moreover, the thickness of the flaps seem to have been reduced to about half the current flap's thickness. Since the flaps have been moved towards the lee side to enhance safety, their mass can be reduced to optimize the Starship's design. This weight reduction will make the flaps more agile, thereby improving navigation efficiency. Additionally, the heat shields on the surface of the flaps are smaller. This change makes sense because smaller tiles are easier to attach, especially in the corner areas of the small component-like flaps. And it's not just the heat shields on the nose cone that have gotten upgrades. Elon's replaced the entire thermal protection system of Starship. These new heat shields are twice as durable as the old ones and have an additional layer of insulation underneath. We've discussed this extensively in earlier episodes, so in this show, we're going to focus on how SpaceX has improved both the manufacturing process and the insulation of these heat shields compared to what they did before. The difference is pretty clear when comparing the new heat shield of Ship 30 to the old one, which is still present on its newer counterpart Ship 32. The first thing that stands out is consistency. The tiles on Ship 32 are scattered, with each tile seemingly having a different shade. In contrast, the heat shield on Ship 30 is much more uniform, differing only in the application method, particularly near complex areas like welds and sensor tiles. Some of this might be due to SpaceX's engineers immediately changing the production process, as SpaceX often does with other components like their engines. Another possibility is the inconsistency in manufacturing methods. SpaceX still has plenty of experience in producing expendable heat shields, but mass-producing large reusable heat shields, well, that's going to require some initial learning. Either way, it's clear that the tiles on Ship 30 are much more consistent. Speaking of the new heat shield, Ship 30 might be the first to be equipped with this heat shield, but it's certainly not going to be the last. Of course, the change in height is something that cannot go unmentioned. The new version of Starship will be taller than the previous one. In fact, we learned about this when Elon announced 2 new versions, Starship V2 and V3, in April. While V2 is only 3.1 meters taller than V1, V3 has a surprising height, clearly representing an extended version. Starship V3 will stand about 150 meters tall instead of the 124.4 meters of Starship V2 and 121.3 meters of Starship V1, and it may even be taller than the current launch tower right now at Boca Chica. At that size, the 2 stages of Starship V3 are almost identical, with the fins appearing slightly larger and possibly even fixed in place. With these upgrades, Starship V3 will be able to hold 4,050 tons of fuel in the booster and 2,300 tons on the ship, compared to 3,650 tons in the booster and 1,500 tons in Starship V2. With the expected thrust improvements over Starship V1 and V2, V3 could increase from the 7,000-ton thrust of V1 to over 8,000 tons in V2. And finally, as Elon shared, V3 could go beyond 10,000 tons of thrust. This would result in Starship V3 having double the payload capacity of V2, exceeding 200 tons, surpassing all current vehicles. Another feature we might notice is that the hot staging of Starship V2 and V3 differs from V1. Instead of the original vent design, the new version of Starship will now have an interface similar to the N1-style interstage of the Soviet Union integrated into the ship. This has sparked much debate about the increased gravitational forces and how Starship will handle the very high pressures during flight. Finally, a very important improvement is SpaceX's brand new engine. SpaceX's groundbreaking design approach with a Raptor V3 engine is reshaping the aerospace industry. This approach is not just about improving existing technology, it's a comprehensive redefinition of how we think about rocket engines. One of the most important aspects of the Raptor V3 is the integration of components. Instead of having many separate parts, SpaceX is using advanced 3D printing technology to create complex structures with built-in functionalities. This not only reduces weight, but also improves reliability by minimizing the number of potential failure points. The removal of the external heat shield is a remarkable breakthrough. Instead of relying on external protective measures, SpaceX has designed the engine to withstand extremely high temperatures on its own. This not only reduces weight, but also simplifies the maintenance and preparation process for flights. SpaceX's focus on reducing the number of sensors is also noteworthy. While sensors are typically considered essential for monitoring engine performance, they can also be a source of failures. By designing an engine capable of self-regulation and tolerating some faults without external intervention, SpaceX is greatly enhancing the overall reliability of the system. In terms of performance, the improvement in the specific impulse of Raptor V3 is impressive. The increase from 330 to 350 seconds may not seem like much, but in the field of rocket engines, this is a significant step. It means that Starship will be able to undertake longer missions or carry more payloads with the same amount of fuel. SpaceX's design philosophy is also noteworthy for its flexibility. By building redundancy into the overall system through the use of multiple engines rather than each individual one, they can take greater risks in the design of a single engine. This allows them to push the boundaries of performance and innovation. Finally, SpaceX's approach to rapid and iterative development is changing the way the industry operates. Instead of spending years on a perfect design, they continuously improve and adjust, learning from each iteration in flight. This allows them to progress much faster than traditional methods. In addition, the new Raptor engine is breaking records in terms of performance. Although we don't yet have specific figures for the vacuum version, it's expected to have a superior specific impulse. Surprisingly, despite these significant improvements, the new engine's lighter than its predecessor. From 3,530 pounds, the weight's been cut by 170 pounds. An impressive achievement for a machine that can consume several tons of fuel a second. This weight reduction was achieved by eliminating unnecessary components and applying advanced manufacturing techniques. SpaceX has minimized the number of flanges and welds, creating a more seamless structure. This not only reduces weight, but also improves reliability by eliminating potential failure points. However, the new design also brings challenges in maintenance. Elon has admitted that in some cases, the only way to access internal components is to cut the engine open. This is a trade-off SpaceX is willing to accept to achieve optimal performance. With 35 engines on a Super Heavy Block 2 or V2 booster, the total weight of the engine system, including related hardware, is about 60 tons, over a quarter of the total weight of the whole booster. Musk has mentioned that there are still many opportunities for further optimization, especially in reducing the weight of the hardware and the onboard propellant supply system. These improvements illustrate SpaceX's revolutionary approach to rocket engine design, where every gram is calculated and optimized for maximum performance. If a rocket launch is like a beautiful dance performance, then the launch tower is the stage on which this glorious spectacle takes place. And for the dance to be perfect and safe, we need a sturdy stage, and SpaceX has excelled at providing just that. They've developed large launch towers, continuously improved their performance over time, and it's even cost-effective. This completely humiliated NASA's scientists and its mobile launch tower. And why's that? What problems is NASA facing with its own launch tower? Okay, so recently, rocket enthusiasts are likely immersed in a lot of hot news, from the Boeing Starliner disaster to the upcoming Starship flight and SpaceX's drama with the FAA. But let's not forget that right at Starbase, there's a massive engineering project worth noting, arguably the tallest ever, that is steadily progressing. It's none other than Starship's Orbital V3, also known as the second launch tower at Starbase. Foundation got laid on June 13th, and to date, it has reached the 7th segment of the tower assembly. In reality, stacking the tower could have probably been quicker, as the first 6 segments of the tower demonstrated SpaceX's impressive speed. The construction of the launch towers proceeded at a remarkable pace. After completing a solid base with piles, steel plates, concrete, and foundations, the company began installing the Orbital V3 modules at a dizzying speed. July 11th marked an important milestone when the first module was placed on the base. Just 5 days later, on July 16th, the second module got stacked, and continuing this pace, the third and fourth modules were installed on July 18th and 25th. Particularly impressive was the installation of the last 2 modules. Just a week after the fourth got done, the fifth module was neatly placed into position August 2nd, and only 2 days later, on the 4th, the 6th module also got fully installed. On average, SpaceX took less than 4 days to complete the assembly of each tower segment. That is an insane speed, far surpassing their previous efforts and setting a new standard in the space industry for the speed of constructing rocket launch infrastructure. However, on the other hand, it took SpaceX up to 12 days to begin and complete the stacking of the 7th tower segment. So, what caused this rapid pace to get interrupted? As we know, SpaceX is currently using the DMAG CC-8801 to stack the pre-assembled modules for their newest Starship launch and landing tower in Boca Chica. A few days ago, the crane was lowered for extension, adding new parts to the boom, main boom, and jib. On August 9th, the extension work was completed, and the crane was raised with the upper part of the boom resting on a replacement support. While being raised, the backstop hydraulic cylinders, which are supposed to retract as the boom's raised, seemed to have locked and then tore free of their mounts as the pressure built. SpaceX proceeded to repair and reconfigure the crane. The result was admirable. The crane got back in operation, towering magnificently across the Starbase sky. To be honest, this was just a minor setback in SpaceX's construction process, and we shouldn't worry too much, as the pace of work will surely recover in the near future. New work at the launch tower will soon prove this, and we can expect progress at the new launch pad in the near future. Yes, you heard that right. It's a new launch pad. Of course, it's not just a launch tower being built, as it's simply one part of the overall structure. 2 weeks ago, we got an announcement from SpaceX that they plan to extend the launch pad area, including adding new water and fuel tanks to support 2 launch pads. A map released by the FAA has shown us some of SpaceX's plans for expanding the Orbital Pad B. Although the new design indicates that the current orbital pad will look very different from the proposed version, it still aligns with what we expect from SpaceX. They're also constructing a flame trench, and a space engineer posted a simulation on X of how this project might look once completed. None other than the space engineer. Thanks to him for making these awesome renderings. Surely the end result's going to be something awesome that we all look forward to. But let's wait and see. But what's equally exciting is when the launch tower actually becomes operational. With the distinction between a catching tower and a launch tower, similar to the proposed application before the FAA in Florida, the exact roles of the 2 launch towers in Boca Chica, Texas, remains a big question mark. Let us know your thoughts down there in the comments. Okay, everything that SpaceX has done and is doing truly leaves NASA's scientists in awe compared to what they've developed for NASA's missions. Yes, it's exactly what I'm talking about, the mobile launch tower, the system that serves to launch NASA's vehicles in the Artemis missions. The first version, Mobile Launcher 1 ML1, was built in 2009 as part of Constellation's program. After the above program was canceled, it was developed into a system to launch SLS Block 1. The total time from its appearance, conversion to completion was about 10 years, with an estimated cost of about $1 billion. Until November 2022, ML1 was used in Artemis 1 mission. After that mission, ML1 got damaged and had to be repaired in time for Artemis 2 mission with a crewed flight. That's all NASA has got after more than a decade with a ton of funding. Even more disappointing, it will apparently only be used 2 more times with Artemis 2 and 3. From Artemis 4, the SLS Block 1B version is going to be used. It'll require a taller and heavier launch tower. That's why NASA has developed a new mobile launch tower system. The second tower, ML2, was designed by this agency to serve the launch of SLS Block 1B and Block 2 of the Artemis 4 missions. It was planned in 2019 and construction started the following year. The main contractor to build ML2 is Bechtel. Initial construction work on ML2 was expected to be done by early last year. The initial cost for the construction of ML2 was $383 million. However, to date, the initial deadline has passed, and Bechtel has not yet completed the construction of ML2. Rising costs and delays have prompted NASA's Office of Inspector General to investigate. And surprisingly, the investigation showed that the total cost has reached $960 million. That's 2.5 times the initial estimate. Along with increased costs, Bechtel's launch tower handover to NASA has been delayed until October 2025, more than 2 years behind the original contract. Even many audits showed that Bechtel may not meet that deadline. Bechtel explained the delay and increased costs due to the impact of COVID-19, as well as an increase in prices. But the cause is considered to come from both sides. NASA rushed to give the contract to Bechtel before the ML2 system specs were finalized. As for Bechtel, they underestimated the scale and complexity of this project. That leads to subjectivity and ineffective operations, leading to delays and increased costs like we just talked about. Thus, it probably took them another half a decade or more to complete their second mobile launch tower. If last year's investigation cost nearly $1 billion, how high is the total cost going to be when everything's all said and done? Some people will say the pandemic's greatly affected the work of NASA and its contractors. However, that reason's not really convincing. Take a look at SpaceX. Around the same time, they developed a new launch system, the Mechazilla system, and OLM. From OLM's first concrete piles in July 2020, and by the end of 2021, OLM and the launch tower were basically completed. This shows that the more reasons NASA and Bechtel give, the more their ineffective operations get exposed. However, in any case, it's clear that catching Starship is still a challenge for SpaceX's launch towers. The company has dramatically complicated the process of testing early Super Heavy and Starship recovery and thus reuse by fully removing traditional and predictable landing legs and designing its latest prototypes such that the only way they can be recovered in one piece is with a giant mechanized launch tower. For a booster or Starship catch, the rocket approaches the tower, enters the gap between the splayed arms, hovers in place while the arms close around it, and eventually comes to rest on hard points that appear to offer about as much surface area as a coffee table. Based on a simulation of the process shown by Elon, calling it a catch is a misnomer, as the arms basically move in one dimension. They open and close and can't actually grab the rocket in any real sense. As built and shown, they're closer to a tiny fixed landing platform capable of minor last-second positional adjustments. Eventually, chopsticks could have a small amount of time off of post-recovery processing, removing the need for a crane or the same arms to attach to a landed booster or ship. They could also shave off the dry mass required for landing legs, though all interplanetary ships are still going to need legs. However, they will also inherently make proving their own efficiency a nightmare. By all appearances, the current recovery mechanisms on the arms and the landing hardpoints on the ships and boosters mean that a catch could fail if either stage is more than a foot or two off from a perfect bullseye or rotated a few degrees in the wrong direction. With the method SpaceX has devised, even the tiniest error could easily end with a massive, pressurized, partially fueled rocket destroying the chopsticks and dropping a few hundred feet to the ground, guaranteeing an explosion that could damage surrounding infrastructure or start fires. In the event of larger anomalies during a landing attempt, Starship or Super Heavy could accidentally impact the launch tower, damaging or even outright destroying the skyscraper-sized structure. We really don't hope it hits the tower. Yeah, exactly. And especially not that launch ring, which is really hard to make. So that launch ring is quite complicated. Ultimately, the immense risk posed by any catch attempt means that unless SpaceX has miraculously gotten the design of everything involved nearly perfect on its first try, the company will have to be extraordinarily cautious and expend a large number of ships and boosters to avoid rendering its only Starship launch tower unusable. At least to some extent, SpaceX likely knows this, and Super Heavy would likely need to be in excellent health and perform perfectly during the ascent and boost back portions of its launch debut to be cleared for a catch attempt. Ultimately, Starship's first orbital launch could end up being even more of a spectacle than it's already guaranteed to be. Finally, we have to wonder what made Elon decide to act so recklessly. Understandably, the payoff on a bet like this is incredibly huge. If the tower can catch the rocket and move it back into position on the launch pad, That could help SpaceX reuse their rockets faster than ever. The highest turnaround time for a Falcon 9 booster from the previous flight to reflight is 27 days. In March of 2020, Musk said that he wanted Starship to be able to fly 3 times a day. This will be one of the most ambitious features of a spaceflight project, already breaking new ground. If Elon wants to build a city on Mars by 2050, he might come to depend on that rapid turnaround time. In 2019, he estimated that the city would require around 1 million tons of cargo to reach self-sufficient status. If each ship carries 100 tons, that means SpaceX will need to make 10,000 flights over the next 30 years, or around 333 a year. SpaceX is, for all intent and purposes, the current state of American spaceflight. Sure, there's that Boeing rocket, but we've all seen how that's going. Yeah, complete disaster. SpaceX is now how NASA gets stuff done. However, by no means is the path to SpaceX's new glory without its own obstacles, and one of the biggest rocks in the road is the government's FAA agency. Recently, the company faced big trouble with the FAA, and this could possibly affect the next Starship flight. So, what happened? It seems that the development of SpaceX has not pleased everyone. As we know, to expand its operations at the Starbase in Texas, SpaceX has proposed to the National Environmental Agency, the FAA, to increase the number of launches and landings of the massive Starship to 25 times a year. Of course, this also means the construction of various engineering structures to support these launches. Things like launch pads, towers, and systems for fuel and water supply. Keep in mind that the head of Tesla also wants his rocket company to have the same kind of massive power as the production and sale of their EVs. For rocket enthusiasts like us, this is a major development. If FAA allows this, it's going to be a big opportunity for SpaceX to take yet another giant leap in space exploration and usher in an era for the entire world. However, some groups who seem obsessed with environmental issues argue that this could be a disaster, potentially destroying the Earth's already beautiful flora and fauna. Now, I'm not saying SpaceX's actions aren't going to impact the environment, but I'm pretty sure SpaceX and Elon already know their limits. And the so-called destruction, as some claim, that's exaggerated and simply not true. Haters, anyone? Recently, a similar issue arose. According to CNBC, SpaceX has been accused of violating wastewater regulations at its Boca Chica launch site in Texas, polluting nearby waters. The news agency reported that they've obtained investigation records and notices sent by the EPA and the Texas Commission on Environmental Quality to SpaceX regarding violations related to their Starbase facility. In a lengthy post on X, Elon Musk's rocket-making company responded, calling CNBC's article factually inaccurate and saying that the system protects the launch site and the surrounding area. Musk himself responded to the post, simply writing, "CNBC sucks." Fake news? We think so. Typically, Elon doesn't pay much attention to legal issues, but in this case, the situation seems to have escalated so much that he had to speak up, and SpaceX had to issue a lengthy explanation. Starbase is where Starship, a reusable transport system that SpaceX is developing and testing with the hopes of sending humans to the moon and one day even Mars, is located. However, the violations SpaceX is accused of could jeopardize future launches and put the company at legal risk. Starship's first test flight last year left behind a bit of a mess. The massive spacecraft exploded in the air and the test wrecked the launch pad. Flying debris smashed into at least one car nearby, and the plume of dust reportedly reached residents several miles away, as well as nesting grounds for endangered birds and sea turtles. Starbase lies on the Texas Gulf Coast near wetlands and wildlife refuges. After the explosion, CNBC said SpaceX scrambles to rebuild the launch pad and install a water deluge system meant to blunt the tremendous heat, energy, and sound from their launches. The company skipped a permitting process in its rush, according to CNBC. EPA then launches a probe and demands more info on wastewater discharges about a month after SpaceX ran a full-pressure test of the system in July of last year, CNBC says. The agency reportedly notified SpaceX March 13th that it was in violation of the Federal Clean Water Act. Regardless, SpaceX moved forward with its third test flight on March 14th. Continuing to use the deluge system during launches without proper permits in place raises the legal risks, per CNBC. SpaceX eventually applied for a permit, reportedly more than 100 days after it got notice from EPA. TCEQ performed a compliance record review to determine whether SpaceX was following wastewater regs on July 25th of this year, according to CNBC. It determined SpaceX had released industrial wastewater without a permit 4 times since March. It also says that TCEQ has received at least 14 complaints in the region, alleging environmental impacts from SpaceX's deluge system. TCEQ sent its notice of violation to SpaceX last week. SpaceX did not respond to a request for comment, but its post on X claims that the EPA and TCEQ allowed it to continue using the deluge system and that it was operating under a separate permit system. Throughout our ongoing coordination with both TCEQ and the EPA, we've explicitly asked if the operation of the deluge system needed to stop, and we were informed that operations could continue, it says. The company also claims that its deluge system causes no harm to the environment. It says it sends water, air, and soil samples from near the pad to an independent accredited laboratory after using the deluge system. So far, it says those tests have shown negligible traces of any contaminants. But the story doesn't end there. CNBC's report continues to challenge those claims, especially when it comes to mercury. SpaceX says its samples show either no detectable levels of mercury whatsoever or found in very few case levels significantly below the EPA limit that's maintained for drinking water. SpaceX followed up with another response on X saying there may be a typo in one table of the initial TCEQ's public version of the permit application. Due to all this controversy and the inability to independently verify these reports, requests for records have been made to EPA and TCEQ, but neither agency has immediately confirmed the accuracy of the allegations. On Monday, FAA postponed meetings initially planned for this week with the intention of discussing draft environmental assessments for SpaceX's plan to increase the launches and landings of its Starship Super Heavy vehicle scheduled at the Boca Chica landing site. 2 hearings were scheduled on August 13th in South Padre Island, Texas, and 2 more on August 15th in Port Isabel, the 2 towns that are closest to Starbase. An additional virtual public meeting scheduled for the 20th has also been called off. When asked why the meetings got delayed, a spokesperson for FAA said it was waiting on additional documentation from SpaceX, but would not share what those documents are. Although CNBC soon followed on August 13th, the final outcome is still pending. But regardless of how it turns out, this is a major challenge SpaceX is going to need to overcome. It's not clear what impact this will have on plans for SpaceX's next Starship test flight, the 5th for the vehicle. The company said August 8th that both the booster and Starship's upper stage are ready to fly pending regulatory approval. However, even if this delays SpaceX's larger scale projects, the company still has got to comply with U.S. regulations. Speaking of which, we recall SpaceX's previous legal lawsuits. To be honest, environmental regulations can be quite cumbersome, acting as a barrier that could disrupt the launch frequency of most rocket companies. Between mid-2023 and early this year, SpaceX repeatedly faced legal challenges related to the environmental impact of its launches. Most recently, a case was in June when the environmental group SaveRGV accused SpaceX of discharging industrial wastewater without a permit into an area about half a mile from the launch pad. SaveRGV then notified SpaceX of their intent to sue for violating the Clean Water Act. If the notice from TCEQ is accurate, this could be one of the reasons. Furthermore, the process of meeting the launch qualification standards set by government agents like FAA or wildlife organizations takes a bit of time. Elon has been notably unhappy about this and spoke about deregulation during an extended conversation with Donald Trump on X. If you deregulate, have sensible regulations, he said, because a lot of the regulations are nonsensical and cause the cost to be extreme for no reason. As someone who's always focused on economic development for U.S. companies and businesses, Donald Trump, if elected, would likely work to reduce these regulations, whether or not Elon suggests it. From what I know, he did implement similar actions during his time as president. It's not just at Starbase, Texas that SpaceX is facing scrutiny from regulations and environmental groups. The company's expansion plans at Cape Canaveral in Florida are also under watch. Famous as the base for NASA launches, the U.S. Department of the Air Force is currently assessing the environmental impact of building a new launch pad at Cape Canaveral for Starship and has recently held a series of public meetings in the area to gauge local opinion. One of the proposed sites for the rocket would involve redeveloping an existing launch pad, but the other, a potentially more controversial plan, would mean building an entirely new one near the perimeter. These places are used to the impacts of the space industry, says Barmeyer, Deputy VP of Conservation Programs of the National Park Conservation Association in the U.S. But what we're seeing right now with new proposals is that they're starting to get closer and closer to protected areas, and that's what we have concerns about. The Cape is surrounded by internationally important plants and wildlife, including Merritt Island National Wildlife Refuge, one of the most biologically diverse areas in the world. The Cape has approximately 1,133 species of plants, 141 species of fish, 74 amphibians and reptiles, 318 birds, and 29 different mammals within its boundaries, says Don Dankert, who heads the environmental management team at NASA's Kennedy Space Center at Cape Canaveral. 21 of these species are federally protected, such as manatees, sea turtles, and bald eagles. NASA's been monitoring the impacts of launches from the area for more than 40 years, beginning with early flights of the space shuttle. In a statement, NASA told the BBC that after 135 launches over a 30-year period, the primary impacts were the accumulation of aluminum particulates, damage to vegetation, and temporarily reduced pH in adjacent waters. NASA attributes these effects to the propellant burned in the shuttle's solid rocket boosters and says similar results were recorded after the November 2022 launch of Artemis, which uses the same solid rocket technology. The agency says it also monitors water and air quality, that the acute impacts of space shuttle launches to wildlife populations were minimal. All vehicles used in NASA launches are tested extensively before they're allowed to depart, says Dankert. Part of that process is ensuring that environmental impacts from these launches are minimal and will not cause long-term damage to the ecosystem. The same cannot be said for the Russian equivalent, the world's first spaceport in Kazakhstan, a cautionary tale of unregulated space ambition. Vast areas of the flat steppe have been poisoned by carcinogenic fuel that spilled out of the discarded rockets. It could in fact be argued that locating Cape Canaveral Launch Complex where it is has actually helped protect the environment. Much of the nearby Florida coast has been overdeveloped with hotels, restaurants, and apartments. The epitome of paving paradise to put up a parking lot, as the Jimmy Buffett song goes. But because of security concerns and the risks of explosions, no one can build too close to the launch site. All right, so the battle of the big rockets is heating up. While SpaceX reigns supreme right now in the rocket industry, somehow Blue Origin has risen after a relatively long period of silence. Jeff Bezos, who likes to talk a big game even though he never has much to show for it, is now confident because all that's set to change at the end of September of this year. Blue Origin's New Glenn is now ramping up preparations for its maiden flight a little bit more so than we thought. As we approach the end of 2024, space enthusiasts like us can't help but feel excited, as this time of the year is an ideal one for space companies to complete their unfinished goals in a fulfilling way. So, what do we have to look forward to in September? It's the launch schedules of a series of new rockets from the giants in the U.S. space industry. We got Vulcan from ULA with its second certification mission, there's SpaceX's Starship with its fifth test flight, and most notably, the debut launch of New Glenn at the end of September. This is the latest and only orbital rocket from Blue Origin, a company that's been a fierce rival of SpaceX for 20 years now. Okay, so many people might find it hard to believe, and some might even think of it being like the turtle, but Blue Origin is finally close to its first finish line. But perhaps now is the moment when the turtle's making its fastest sprint yet, as evidenced by the latest interview video from the famous space YouTuber Everyday Astronaut with Blue Origin's leader, Jeff Bezos. Through this, Blue Origin wants to show all of us how well prepared they are for New Glenn's first orbital flight. This is a big media move and a new step forward for Bezos, especially in light of the criticism that he and his company, among many, have faced over the years. Finally, he's got an orbital rocket and confidently boasts about this beloved creation. With a tentative launch date of September 29th, New Glenn seems almost ready from a manufacturing standpoint, although its parts are not yet fully put together. In fact, we've only seen a mock-up of New Glenn's first-stage hardware at Cape Canaveral and haven't actually seen a rocket ready for flight. Regardless, though, Blue Origin has to be prepared for its first mission. The mission, named Escapade by NASA, is a mission to Mars, and the provider recently announced that 2 small spacecraft arrived in Florida to be ready for the flight coming soon. Accelerating to meet this, Blue Origin has conducted a series of test flights on various modules over the past few months. But before we dive into those tests, let's talk about the structure of the New Glenn rocket. The New Glenn rocket is an orbital rocket made of 2 stages, each consisting of smaller modules, aft, mid, and forward. Starting with the first stage of the rocket, the forward module is essentially the top of the booster. We can see this more clearly in the Bezos interview video, as he explains.
And what you see, that the fabric covering is our thermal insulation.
Oh,
so
cool.
we developed that ourselves, and it's highly reusable. It's been tested on New Shepard.
The mid module houses the fuel and oxidizer tanks. Made from aluminum, these tanks are designed to withstand the significant G loads encountered during re-entry. The aft module stands as a powerhouse, housing 7 BE-4 engines. These engines, known for their restartable capability, provide precision thrust vector control and continuous deep throttle capability. Bezos said,
"There are 3 gimbling engines on this vehicle and 4 fixed engines that don't gimbal. So there's a line of 3 engines. For the return, we light the 3 gimbling engines to do the full deceleration, and then we do the final landing on a single engine."
The aft module proudly features 6 deployable landing legs. This is a vital component for the precise landing operations of the stage on the drone platform in the Atlantic. Bezos also hinted at the capabilities of these landing legs during the interview.
The landing gear deploy starting 14 seconds from landing. They deploy. It takes them 8 seconds to deploy.
Okay.
So they're fully deployed 6 seconds before landing.
Okay.
The deployment is gravity assisted because you're decelerating.
Yep.
So you've got good gravity assist on the gear deployment.
Moving to the forward module completes the trio. 4 actuated aerodynamic control fins for attitude control during descent. It also serves as the housing for ground umbilical connections for New Glenn and the interstage housing for the 2 second-stage vacuum-optimized BE-3U engines. Within this section, crucial avionics, including an autonomous flight safety system, are integrated to ensure precise control throughout the mission. Advancing to the second stage now, it comprises an expendable liquid hydrogen stage with a dual gambling BE-3U engines, boasting a total thrust of 1,600 kilonewton or 240,000 pounds force in a vacuum. The second stage, with a diameter of 7 meters or 23 feet, has a length of 16.1 meters or 52.9 feet. The overall length, inclusive of the 2 high expansion ratio nozzles, is 23.4 meters. Similar to the first stage, the second one is segmented into aft, mid, and forward sections. Additional key features of the New Glenn architecture include the pneumatic pusher stage separation system located in the forward module. This system ensures positive separation before the ignition of the second stage, contributing to the overall reliability of the launch. What tests has Blue Origin conducted on the individual modules of New Glenn? Over the past few months, Blue Origin has carried out several tests on New Glenn's hardware at Launch Complex 36. These tests are essential for gathering data before the rocket's first flight. At the beginning of July, recovery tests for the New Glenn transporter erector system were conducted at LC-36. These tests involve pulling the large TE away from the vehicle and disconnecting the umbilical from the first and second stages. Blue Origin completed these tests within a few days before lowering the TE and mock-up stages back up to the horizontal position and rolling them back inside the hangar. Meanwhile, a New Glenn first stage aft module was spotted at the test area, located about 150 meters from the launch pad. Blue Origin later confirmed that the aft module was being tested, specifically demonstrating the development of 6 landing legs housed inside the module. The company's CEO, Dave Limp, confirmed that the aft module was flight hardware. This test indicates that the company's ambition to attempt a first-stage landing on New Glenn's maiden flight. The forward module was moved towards LC-36 July 25th, and Dave Limp posted on X that the module's completed validation tests, including the activation of the reaction control system, which is crucial for controlling the booster in zero gravity and during landing, as well as the 4 large fins that help steer the booster. Both these systems are vital for making New Glenn's first stage reusable. On August 8th, the second stage of New Glenn was spotted outside Blue Origin's factory at Exploration Park, as well as being transported to LC-36. Dave Limp confirmed on X that this stage is flight hardware for the rocket's first mission. The second stage is expected to undergo tests at the launch pad before getting integrated with the first stage, which is also expected to get transported to LC-36 in the near future. So, let's consider whether Blue Origin really can catch up with SpaceX. Many believe that calling SpaceX and Blue Origin rivals is like saying the New York Yankees and a Little League team are rivals. There's really not much of a comparison to make. No offense. Much like SpaceX's next-gen Starship rocket, Blue Origin started work on its semi-reusable New Glenn rocket in the early 2010s. Both were massive, meant to be powered by huge new methane-oxygen-fueled engines, and designed from the ground up with some degree of reusability in mind. But with fairly different designs and wildly different development philosophies, the paths of Blue Origin and SpaceX have only gone further apart in these last 6 years. SpaceX thoroughly redesigned its next-gen rocket multiple times before throwing out a large portion of that prior work and settling on an unexpected stainless steel variant that Elon christened as Starship in late 2018. Further differentiating the companies, SpaceX started work on steel prototypes almost immediately and successfully built and flew a scrappy Pathfinder, powered by an early version of the same Raptor meant for Starship less than a year later. SpaceX then improvised a factory out of a series of tents and began churning out and testing dozens of more refined prototypes, 7 of which would go on to do flight tests between August 2020 and May 2021. SpaceX's last test flight ended with a full-size steel Starship prototype successfully landing after launching to an altitude of 10 kilometers. The testing process significantly slowed down after that success, but in 2023, SpaceX did its first 2 orbital test flights. That orbital launch debut has been more or less continuously delayed for years and is about 26 months behind a tentative schedule Musk first sketched out in 2016. Technically, the same's true for Blue Origin, which also said it intended to debut New Glenn as early as 2020. However, while SpaceX can point to the instability of Starship's design before 2019 as a fairly reasonable excuse for delays, the general characteristics of New Glenn's design appear to be virtually unchanged despite their many delays. The smaller rocket, 7 meters wide and 98 meters tall, to Starship's 9-meter width and 121-meter height, will use traditional aluminum alloys for most of its structures, will be powered by 7 BE-4 engines, will land on several deployable legs, will have expendable upper stage powered by 2 BE-3U engines, and will be topped with a large composite payload fairing. In short, Bezos probably wants Blue Origin to go slowly but surely like the tortoise, but perhaps for this race, the SpaceX bunny never stopped to rest. SpaceX is no stranger to breaking records with its Falcon 9 rocket. Every few months, it seems like we witness another reuse record getting set, up to 22 reuses of a single rocket. However, a record that's not often broken is the frequency of rocket launches from launch pads. Recently, SpaceX once again demonstrated its relentless ability to improve by breaking this challenging record. The company completed 1 launch within just 2 days, paving the way for significantly increasing the frequency of SpaceX's future space flights. SpaceX suspended flights of its flagship Falcon 9 rocket for 15 days last month as engineers investigated why an upper stage failed to deliver a batch of Starlink internet satellites to the correct orbit. After resolving the technical issues, SpaceX demonstrated incredible resilience. Conducting 10 missions in 19 days is a testament to this company's awesome operational efficiency and logistical capabilities. This means SpaceX right now is currently launching at a rate of 1 launch every 2 days. That's the fastest pace the company's ever achieved. If SpaceX can maintain this pace till the end of the year, the target of 148 launches for 2024 is going to set a historic record in the U.S. aerospace industry and for SpaceX itself. The variety of missions carried out in this short period is also noteworthy. Although most of the flights focused on deploying Starlink satellites, a crucial part of SpaceX's business strategy, the company still managed to perform missions for outside customers. This includes launching the Singus supply ship to the ISS, a vital mission for the station's operations. Deploying communication satellites for Norway to cover the Arctic is an example of how SpaceX is contributing to improving global connectivity, particularly in remote areas. Additionally, launching high-res Earth imaging satellites for Maxar highlights SpaceX's role in supporting advanced Earth observation applications. This rapid launch pace not only showcases SpaceX's technical prowess, but also reflects the growing demand for satellite launch services in the commercial space market. This could be a sign of rapid growth for the space industry as a whole. So far, SpaceX has conducted over 83 Falcon 9 and Falcon Heavy launches. This means an average of 1 launch in less than every 3 days, so SpaceX's launch teams are well accustomed to launching rockets at high frequency. However, maintaining such a high launch rate presents numerous challenges and limitations. Managing 3 launch pads in 2 different states, Florida and California, requires tight coordination and detailed planning. Each pad needs to be maintained, prepared, and turned around between missions, requiring a continuous workforce of technicians and support staff. Another challenge is producing entirely new second stages for each mission. Unlike reusable boosters, the second stage of Falcon 9 is designed for single use. This requires SpaceX to maintain a continuous production line to meet the demand for frequent launches. The availability of drone ships for offshore booster landings is also a critical factor. These ships need to be maintained, refueled, and moved to the appropriate location for each mission. Managing this fleet requires close coordination with the launch schedule. SpaceX has been smart in using mission configurations that allow boosters to land on land when possible. 3 of the last 10 flights use this method, reducing pressure on the offshore landing fleet. This is one reason, along with possibly reserved upper stages, that SpaceX was able to launch so many missions over the last 19 days. Besides, recently, SpaceX announced a new mission that stands out not only as a contribution to the company's already dazzling rocket records, but also as a milestone in the history of space travel. The mission, named From-2, was unveiled August 12th and is scheduled to launch later this year. This will be the first crewed mission to explore Earth's polar regions. If all goes according to plan, From-2 will launch on a Falcon 9 rocket from Florida's Space Coast later this year, carrying 4 astronauts into orbit aboard a Crew Dragon capsule. This spacecraft will not dock with the ISS, but instead orbit the Earth independently. Throughout the 3 to 5 day mission, the crew plans to observe Earth's polar regions through Dragon's cupola at an altitude of 425 to 450 kilometers, leveraging insight from space physicists and citizen scientists to study unusual light emissions resembling auroras, SpaceX wrote in the mission description. The crew will study green fragments and ribbons of continuous emissions comparable to the phenomenon known as STEVE, which stands for Strong Thermal Emission Velocity Enhancement, which has been measured at an altitude of approximately 400 to 500 kilometers above the Earth's atmosphere, the company added. The From-2 will also study how spaceflight affects the human body. This work will include capturing the first ever X-ray image of a human in space. This mission will ultimately contribute to increasing the total number of private spaceflight missions to 6 to date, and of course, will be part of the ongoing development of Falcon 9 launches. Contrary to SpaceX's very busy launch schedule, Russia's space agency has been embarrassingly scarce in their rocket launches. In February of this year, the head of the Russian Space Agency announced a goal of 40 rocket launches for the year. Now, in the latter half of 2024, Russia should have reasonably achieved at least half of those proposed launches. However, sadly for the former Soviet Empire, including the most recent launch of the Progress MS-28 cargo ship August 14th, Russia has only done 9 orbital launches over more than 8 months. There are numerous reasons for this, including decisions by Western space powers to distance themselves from Russia's space conglomerate Roscosmos following the invasion of Ukraine. This has led to catastrophic effects on Russia's space program, but only recently have we gained deeper insight into the extent of this impact. A financial crisis is unfolding in Russia. Roscosmos' revenue fell to 10.5 billion rubles in 2021 from 32.3 billion rubles in 2018. The space agency appears to have sunk deeper into a financial quagmire as demand for satellite launch services, a primary source of foreign currency, has evaporated following the invasion of Ukraine. As a result, Russia's space industry has been operating at a loss in recent years and may not even break even until next year. Although Russia is doing its best to recover from the ongoing disaster by creating a new space economy, major projects seem to lack a clear future. Russia is also developing the Russian Orbital Space Station, or ROS, which has been frequently delayed. Current plans for launching a science and energy module in 2027, with the core of the station, 4 modules, to be put into orbit by 2030. Subsequent expansions will occur in the early 2030s. However, it should be noted that these dates can generously be described as highly ambitious. Even more speculative are future rocket projects announced by the space agency, including the Amur LNG vehicle and the Corona rocket. In 2020, Russia set a goal to launch the methane-powered, reusable first-stage Amur rocket by 2026. This vehicle was developed to be cost-competitive with SpaceX's Falcon 9. Yelkanov now says that Roscosmos intends to develop reusable first stages in 2 phases. In the first phase, a Grasshopper-like program will test landing technologies before moving on to testing with a complete booster, but don't expect to see Amur anytime soon. Meanwhile, other countries are eager to make up for Russia's delays. India has launched 46 satellites for foreign customers last year, tripling its number from 2021. Low cost is India's strength, said Kazukai Shimonatai, a director at PwC Consulting. China's annual launches for foreign customers usually fall below 10, but the company has pledged to become a major space power. According to Euroconsult, the global space business market, excluding manned flights, is likely to increase from $12.2 billion in 2023 to $15.8 billion by 2032. The space consulting firm expects a severe shortage of rockets in the next 10 years as competition intensifies. European countries are not the only ones building rocket launch sites. Approximately 100 such projects are currently underway worldwide. Japan has two launch sites, one in Tanegashima, a volcanic island between the East China Sea and the Pacific Ocean, and the other in the Kagoshima Prefecture, near the tip of the country's southernmost main island. Busy with government projects, neither site has sufficient capacity for the private sector. All 34 satellites that Japan currently has in orbit were launched by foreign rockets. Despite the lack of launch capacity and the often complex and time-consuming process of outsourcing launches to third parties, Japan has been slow to join the launch pad construction boom. However, the country's technology and entrepreneurial spirit are well suited for a viable space industry. The Japanese Aerospace Exploration Agency successfully launched the new H-3 rocket February 17th. On February 6th, the Japanese government announced plans to develop public-private capacity to launch 30 rockets annually by the mid-2030s. However, this is a daunting task considering the country only conducted 2 launches last year. That's all for today's episode. Thank you so much, and see you next time.